Hello students, today we will discuss your doubts of test number 17. Okay, so test number 17, you have asked your doubt 52, 57, 60, 62, 63, 66, 68, 69, 70, 71, 72, 84, 88 and 90. Total 13 doubt. See, this chapter is very important chapter regarding exam point of view. So you need to solve, you need to do proper practice in this chapter, okay. Anyways, you have asked this much doubt, okay, and asking, alright, this much doubt is a sign of not practicing questions properly or well. See, anyways, question number 52. Question number 52, we'll go for that. The enthalpy of neutralization of oxalic acid by strong base is this. Oxalic acid, C double bond OH, C double bond OH, and their enthalpy of neutralization with strong base, let's say NaOH. Their enthalpy of neutralization is given. This is minus 25.4 kilocalorie per equivalent, okay, or per mole. So this is the enthalpy of neutralization for this H plus and for this H plus. So for 2, this is diprotic acid. For diprotic weak acid, it is given this much. So for delta H neutralization, that is per equivalent or per proton, is equals to how much? Minus 25.4 divided by 2 is approximately how much? 2 1 ja 2, 2 2 ja 4, alright, 27 minus 12.7 kilocalorie per equivalent. Okay, enthalpy of neutralization of strong acid with strong base. Enthalpy of neutralization of strong acid and strong base is, we know that is minus of 13.7 kilocalorie per equivalent. So therefore, difference of energy of this, that is what we can say. Enthalpy of ionization, if you want to calculate, that is enthalpy of neutralization of weak acid or weak base, weak acid or weak base with strong acid or strong base, minus enthalpy of neutralization for strong acid and strong base. So this is equals to minus 12.7 minus of 13.7 kilocalorie. This is equals to 13.7 kilocalorie minus 12.7 kilocalorie per mole. Whatever the value will be there, that is the answer. So the value is what? 12.7, 13.7, 1 kilocalorie approx. So 1 kilocalorie per H plus. Therefore, alright, for oxalic acid, diprotic acid, 1 into 2 kilocalorie, 2 kilocalorie for alright, 2H plus. So for 2H plus, so per 2H plus per diprotic acid, per oxalic acid molecule, we can say per oxalic acid molecule, per H2C2O4, this will be how much? 2 kilocalories. Where is the answer? 2 kilocalorie. First option, that is B is the answer. Sorry, B is the answer. 2 kilocalorie per mole. Okay. So you might have calculated 1 kilocalorie and put the answer, but that is for 1H plus. For 2H plus, it will be 1 into 2, that is 2 kilocalorie, and answer is B. Question number 57. Question number 57 is, if H2 and O2 gives this much, see, if H2 plus half O2 gives rise to H2O, delta H value is minus 68.09 kilocalorie, then K plus H2O plus water is given KOH plus half H2 and delta H value is given minus 48 kilocalorie. Then KOH plus water gives rise to KOH aqueous. This delta H is given minus 14 kilocalorie. The heat of formation of KOH is, so the heat of formation of KOH, okay, that is K plus H2 plus half O2, half H2, and del H for this reaction will be how much? So these things you need to calculate from the given 3 data. Fine. So we'll get K from the second equation, we'll get H2 and O2 from first equation, and then we'll do that. So first and second, we want half H2 and half O2. So if it is multiplied by half, so we'll get 1 by 2. So this is multiplied by 1 by 2. Then this will be multiplied by 1 by 2. And then these two will be added. First and second will be added. We'll get half H2 plus 1/4 O2 plus K plus, okay, H2O and H2O will be cancelled. Over here half H2O, over here half H2O. So H2O over here, K plus 1 by 2 of H2O will give you the KOH value plus water also, plus water gives rise to KOH plus half H2. See, no need to multiply them by half, because over here half H2, this is H2, so automatically it will come H2. So no need to multiply them by half. So this will be half H2 plus 1 by 2 of O2. Simply we have added these two, will become H2O. H2O will be cancelled, no problem. Then H2O, H2O will be cancelled. So first equation, let's say this is equation number 1, this is equation number 2, this is equation number 3. So 1 plus 2, what you will get? By using 1 plus 2, you will get K plus half H2 plus half O2 plus water gives rise to, because this is being cancelled by 1 by 2 unit, this is being cancelled by the water is left out, KOH in the product side. So you will get this much, and this is another equation. Now what we want? We want this, we want this, we want this. We don't want water and KOH, alright. So over here KOH plus water gives KOH aqueous, right. So what we do? KOH plus water gives KOH aqueous. If it is added, this third equation is also added. So in third equation we have KOH plus water, alright, gives rise to KOH aqueous. Over here taken water, so this is aqueous, I think. Yes. So KOH aqueous. Now subtract this equation. Minus, minus, minus. We'll have water. Water is cancelled. KOH aqueous is cancelled. So we'll get the equation. So net equation will be how much? See, in the net equation we'll get the value of formation of KOH without water. Formation of KOH without water. So how much it is? So first and second equation, that is minus 68.09 plus minus of 48 minus. Third equation is minus of 14. See, this will become minus of 68.09 minus 48 plus 14. Where is the option? B is the option, so answer is B, no problem. Okay. Next is, it was question number 57. Next is question number 58. Question number 60. Next is question number 60. The heat of combustion of ethanol determined in the bomb calorimeter is this. What will be the value of their del E at 298 Kelvin? See, we know that del H is equals to del U or del E plus W. Okay. And now W for bomb calorimeter is equals to 0. Therefore, del U is equals to del H itself, that is equals to minus 670.48 kilocalorie per mole. Where is the answer? B. So B is the answer. Question number 62. 62. If del H of formation of H2O2 liquid and H2O liquid are given, what will be the enthalpy change for the reaction? 2H2O2 liquid gives rise to 2H2O liquid plus O2 gas. Okay, delta H for the reaction is summation of enthalpy of product minus summation of enthalpy of reactant. So enthalpy of formation of water multiplied by 2 plus enthalpy of formation of oxygen minus enthalpy of formation of H2O2 multiplied by 2. Solve this equation, you will get the value. So delta H of water formation is given. It is how much? It is minus 286 into 2 kilojoule per mole plus delta H of formation of oxygen is 0 minus enthalpy of formation of H2O2 is how much? 2 into, that is how much? 188 minus of 188. So minus minus will become plus. 188 into 2. This is the value. So whatever the value you will get, that is the answer. And the given answer is B. So check the answer. I think it will be correct answer. This is question number 62. Next is question number 63. Question number 63. The standard heat of formation of CCl4, H2O, CO2 and HCl are given. For the reaction, what will be the del H? We have reaction CCl4 plus 2H2O gives rise to CO2 plus 4HCl. Okay. For this particular reaction, what will be the value of del H? Similarly, we can calculate, similarly like 62. So del H for the reaction will be enthalpy of formation of CCl4, CO2 plus enthalpy of formation of HCl multiplied by 4 minus enthalpy of formation of CCl4 plus 2 times of enthalpy of formation of water will be the net value of del H, and their answer is given 63D. So I think you will get the answer D by using this relation, putting all the values on the equation. Question number 66. Then question number 66 is, okay, question number 66, enthalpy of combustion of cyclohexane and cyclohexene and hydrogen are given. The heat of hydrogenation of cyclohexane. Enthalpy of combustion of cyclohexene plus hydrogen gives rise to cyclohexane. This is the equation. Okay, for this particular reaction, you need to calculate del H, which is what? Enthalpy of combustion of, alright, enthalpy of combustion of cyclohexane is given. Enthalpy of combustion of cyclohexene is given. So you can calculate, this is enthalpy of combustion of cyclohexane minus enthalpy of combustion of, this is for cyclohexane, minus enthalpy of combustion of cyclohexene plus enthalpy of combustion of hydrogen. Solve this equation, you will get the value. Okay, enthalpy of combustion of cyclohexane minus 3920 minus enthalpy of combustion of cyclohexene minus plus 3800 minus and plus, that is minus delta H of hydrogenation. So delta H of hydrogenation we will take, this we will take minus, and over here minus, this plus, and over here minus how much? 241 kilojoule per mole. So you will get, solve these equations, you will get the value, and the value given is, first option is the correct option. Okay. So simple calculations in this chapter, even though why you are not able to do, I don't know. I think you are not doing practice. So do proper practice. Then after you will be able to solve these type of questions. Alright. Next we'll do the question number 68. Question number 68. Okay, we'll do little letter. We'll do the question number 68. Question is enthalpy change at 298 Kelvin in successive breaking of OH bonds of water are H2O gaseous gives rise to H plus OH, and then OH gives rise to H plus O. All are gases. So add these two. If you add these two, this and this will be cancelled. So H2O breaks to give 2H plus O. Okay. There del H is given, there del H is given, 1 and 2. So what we need to calculate? The bond enthalpy of OH bond. So the bond enthalpy of OH bond. So del H for the reaction is equals to, del H for the reaction is equals to, what we can say? This del H1 plus del H2. This is equals to, del H1 is what? 498 plus del H2 is 428, this much kilojoule per mole. This is equals to 886, 6, 3, 3 and 9, 12, 2, 1, 5 and 4, 9. 926 kilojoule per mole. This is the enthalpy of cleavage of oxygen hydrogen bond. There is 2 oxygen hydrogen bond. So for 2 OH bond, this is the value. For 1 OH bond, this value will be how much? 926 divided by 2 is equals to 2 4 ja 8, then 2 4 ja 8, 2 6 ja 12, 2 3 2 6 463 kilojoule per mole. Where is the answer? It is given. So D. So 68 answer is D. Next is question number 69. Question number 69. 69 number question is spontaneous change in one in which the system suffers lowers in free energy, that is, alright, lowers in free energy. C is the answer. Spontaneous change is due to decrease in free energy, and decrease in free energy is the final criteria for their spontaneity. Already we know that. Then question number 71. 71 question is the enthalpy of formation of C2H4, CO2 and H2O are given. Then enthalpy of combustion of C2H4. C2H4 plus O2 gives rise to 2 CO2 plus 2 H2O. So 2 2 is 4 and 2 6, so 3 O2. So for this combustion, enthalpy of combustion we need to calculate. This is equals to enthalpy of formation of carbon dioxide multiplied by 2 plus enthalpy of formation of 2 into enthalpy of formation of water. Alright, this is the value minus enthalpy of formation of C2H4 plus 0 into 3, because their enthalpy of formation is 0. Solving this, you will get the answer. So 69, 71 answer is given. D, you should check their answer. Okay, by solving this value you will get 2 into enthalpy of formation of carbon dioxide enthalpy of formation of carbon dioxide is minus of 394. Alright, this is the value plus 2 into enthalpy of formation of water, and enthalpy of formation of water is minus 286. Okay, minus this value is given C2H4, enthalpy of formation of C2H4 is 52. Okay, plus 0. So solving this, you will get the value, no problem. This is what question number 71. Now we will go for question number 72. Question number 72. The enthalpy and entropy change for a chemical reaction is this. Predict whether the nature of reaction will be spontaneous or not. 72. For their spontaneity, del G must be negative, which is equals to del H minus T del S. See, enthalpy change for chemical reaction is given. This is minus 2.5 into 10 to the power minus 3 calorie minus, alright, which one? 74, 298 into delta S, that is given 7.4 calorie, alright, degree inverse. So this value will use, and this value will be what? So we'll calculate this value, 298 into 7.4, and this one, if overall value is negative, process is spontaneous. So process is spontaneous. 72 answer is given A. Then 84, question number 84. Question number 84 is, determine the enthalpy of formation of B2H6, alright, for the following reaction. 84, B2H6 plus 3O2 gives rise to B2O3 plus 3H2O. Okay. Determine the enthalpy of formation of B2H6 in the given reaction. Given is enthalpy of reaction is given, enthalpy of formation of B2O3 is given, enthalpy of formation of H2O is given. So enthalpy of reaction is equals to, alright, summation of enthalpy of product minus summation of enthalpy of reactant, summation of enthalpy of product minus summation of enthalpy of reactant. These things you need to calculate. Their formation will be 0. This is given already, this is given, this is given. So this we need to calculate over na. So summation of enthalpy of formation of B2O3. So enthalpy of formation of B2O3 is given. How much it is? This is minus 1273 minus plus 3 times of enthalpy of formation of water, and enthalpy of formation of water is given 241. Alright, 241.8 kilojoule. This is minus value is given. Okay. Then minus enthalpy of formation of B2H6, which we need to calculate. This value is given already, and this value is given how much enthalpy of reaction? That is minus 1941. So all the values are given, only one is unknown. We can calculate the value of unknown. Question number 84. And their answer is given C. Next is question number 88. Question number 88. Okay. Enthalpy of neutralization of HCl by NaH is given, and by NH4OH is given. The enthalpy of ionization of NH4OH. Again, enthalpy of neutralization of HCl by NaOH. So HCl plus NaOH, this value is given. This is minus 55.84. And by weak base is given, NH4OH, it is given. It is how much? Minus 51.34 kilojoule per mole. So just now I said enthalpy of ionization will be minus 51.34 minus plus 55.84. The rest value will be the answer. Answer is given B, and B is the correct answer. We'll get B. Question number 90. The enthalpy change for the following reaction is 368 kilojoule per mole. Calculate the average oxygen fluorine bond energy. So fine. Calculate average oxygen fluorine bond energy. So enthalpy change del H is given. which is how much? 368 kilojoule. And for O2F2, sorry, OF2. So OF2 is having 2 oxygen fluorine bond. So each this and bond energy, alright, is equals to 368 divided by 2. So this will be how much? 2 1 ja 2, 2 8 ja 6, 2 4 184 kilojoule. Where it has the answer? A is the answer. So A is correct option. Okay. So this is all about your doubt discussion of test number 17. Alright, I hope all of you understood how to proceed on the numerical problems on this chapter. Okay, thank you very much. Thank you.